Okay, so we talked about dilation. Dilation, as we wrote in our notes, is when an object gets bigger or smaller. And Mr. Soto gave us that example with your eyes and your pupil dilating, okay, getting bigger or smaller. So I'm going to write that right here. I'm going to write get bigger or smaller. The other words that you can use besides getting bigger or smaller, you might see enlargement, which is the same as getting bigger, or reduction, which is the same as getting smaller. They're synonyms. So gets bigger or smaller, just so we can have this at the top of our paper so we'll know what we're doing is when that object gets bigger or smaller. The other thing that we make special note of is that if it gets we know that it's going to get bigger when k is greater than 1. We know that it's going to get smaller, that object, if k is less than 1. Okay, so just in case you forget what this inequality is, this is greater than, this is greater, and this is less than or less. The word scale factor, the word factor means to multiply. So that may help you with how you make or how you find the new object or the image is you have to use multiplication. Scale factor, the factor part is multiply. Okay. So since the scale factor or K is 3, since 3 is greater than 1, then the object would enlarge. So they want us to use the word enlargement. So that means it's going to get bigger. Since k here is smaller than 1, less than 1, then the object is going to reduce in size. It's going to get smaller. So we're going to put reduction here. Here, k, this is 5/4, which is an improper fraction. This is larger than 1, so it's going to do an enlargement. And the last one, we got some people say 0.93 or 93 hundredths is the mathematical way to say this. This is smaller than 1, so this is going to be a reduction. Any questions about that first section? All right, in the second section, numbers 5 through 8, you're going to tell if it's a reduction, which means it got smaller from A to B, or if it's an enlargement, which means it got larger from A to B. A being the before the move, which is the pre-image, and B is going to be after the move, which is going to be the image. After which, you're going to tell how much smaller or bigger did it get by finding the scale factor. And we're going to use a formula to do that. Okay, so let's go through and write whether it's a reduction or an enlargement. I'm going from A to B. So when I go from A to B, is this a reduction or is this an enlargement? Does anybody know? If I'm going from this A shape to this B shape, is that a reduction or is that an enlargement? Okay, that's a reduction. Very good. Okay. So let's look at 6. Let's see if it's a reduction or an enlargement. We're going to do those first, and then we'll go back and do the scale factor. Somebody different, going from A, it is an enlargement. Good job. Okay. And then number 7, anybody? This is a reduction from A to B is a reduction. Good job. And then number 8, the last one in this section, going from A to B. This is an enlargement. Excellent. Okay. Excuse me. All right, so now we have to go back and figure out how much did it increase or decrease by, okay? And remember, scale factor is multiply. So at how many times bigger or how many times smaller it is. And we were always right in terms of multiplication. Okay, so let's look at number 5 to see how we do that. We're going to use the formula for scale factor, which is K is equal to image, the after, divided by the pre-image, which is the before. Almost like working backwards. Image divided by pre-image. That's the formula. Okay? Make sure that you are muted. I kind of hear some background noise there. All right. So here, in order to do this, we're going to write the pre-image. We're going to pick one point and we're going to write the pre-image. So we go to the pre-image first. The pre-image is A. So we're going to pick one of these points on A object. And I'm going to pick this one right here at the top. This point is 0 and 1, 2, 3. And we're going to take this same point and find that same point on the image. That same point on the image went down here. So we're going to write this point as our image. Any questions about how I did that so far? So this image point is 0 and 1. So it went from here to here, that point. So we got to figure out by using this formula how much times smaller did it get. So we are going to use, wait a minute, what did I put? I put 0. I put 3 and 0 instead of 0 and 3. Sorry, y'all. My mistake. It's 0 and 3. All right, so we avoid using 0 because that's not going to tell us how much bigger or smaller it got. So we're not going to use 0. So we're going to use these y values. And we only need one set of values. So we either use the x's or the y's. It doesn't matter which one you use. If you use you could use the x's, but here you don't want to use 0 because that's not going to tell you how much bigger or how much smaller it got. So we cannot use 0. So when you see 0, don't use that one. You got to use the other x or y. Okay? All right. So I'm going to write, well, I have K right here, so I'm going to use this. So on the top, I'm doing the image number. So the image number is 1. Pre-image is on the bottom. The pre-image number is 3. So this is my answer here. Okay, it reduced by 1/3. It reduced by 1/3. And remember, we know this to be correct because it's a reduction and K is smaller than 1. Any questions about that? Okay, let's look at number 6. We're going to use the same formula again. We have K is equal to image divided by pre-image. Okay. Let me go through real quick, guys, because I can hear a lot of background noises. Okay. All right. We are going to use this formula. So we're going from A to B here. That is enlargement. We're going to write down our pre-image first, then our image. We're going to choose one point. Doesn't matter what point I'm using. I'm going to use this one. Okay. So this point went from here to up here. So this is going to be the image of this point. So that pre-image is going to be start at the origin, 1, 2, and then up 1, 2. So the pre-image is 2, 2. And remember, I could have used any of the other points, okay? But I just decided to use this one. Okay. The image is here, which is 1, 2, 3, 4, 5, starting from the origin, and up 1, 2, 3, 4, 5. So this is going to be 5, 5. So we're going from 2, 2 to 5, 5. So we use this formula to figure out how many times bigger it got. So on the top, we got the image. So I'll just choose whether I want to use the X's or use the Y's. Use one or the other. They both are the same. So we're just going to use the X's because they're both the same anyway. So my image is 5. So I'll put 5 on the top. My pre-image is 2. So I'll put 2 on the bottom. So I can keep this as my answer, even though it's an improper fraction, as long as the fraction is reduced. Or I can write it as a decimal. So in order to write this as a decimal, I divide 2 into 5. This gives me 2. This gives me 4. I have 1 remaining, so I add a decimal and a 0. And 2 goes into 10 5 times, bring up that decimal. So my answer is either 5 over 2 or the decimal 2 and 5/10, or some people say 2.5. So this would be my answer here. Any questions about this? All right, I'm going to leave you 7 and 8 to do on your own. If you want to take a picture of that, please take a picture. I'm going to move on then to number 9. And I'm going to put this video on our online, on our Canvas page. Here we're doing the same thing that we did above, only it's not in pictures. They just gave you the ordered pairs that they want you to use to find the scale factor. A is going to be the pre-image. It's going to be this is going to be, sure. Let me pause my video real quickly. Okay, so again, A for each of the problems 9 through 14, A is going to be my pre-image. This is going to be the starting place. Okay, so I'm going to find the scale factor. So it goes from A to R here, right? So we're going to use the scale factor formula, image divided by pre-image. And we're going to choose either X or Y. All right, doesn't matter because none of these numbers are 0. So I'm going to choose to use X. So X here is going to be 3 and X here is going to be 9. So I'm going to use 3 and 9. Image goes on top, so 9 is on top. Pre-image is on the bottom, so 3 is on the bottom. So my scale factor here, when I reduce this or simplify 9 divided by 3, gives me 3. So K here is equal to 3. This, of course, is an enlargement. Okay, I will do one more. Okay, I'm going to go down to do, see here. Let's do, the line has the endpoints, and these are the endpoints here. And it says use the scale factor to write the other ordered pairs. So we're going to use the scale factor down here to write the other ordered pairs. So here we're going to multiply the scale factor 2 times each of these numbers to figure out what the image is after the move. So I'm going to say 2 times 1, which gives me 2. 2 times 1, which gives me 2. For B, so we go from B to B prime, 2 times 3 gives me 6. 2 times 1 gives me 2. And this is my answer here. This is going to be my image. Questions about that? We'll pause.